The James Webb Space Telescope, also known as JWST, will be the most complex and powerful astronomical space observatory ever built. It will launch next year and perform the series of mechanical deployments shown here before arriving in orbit around the Sun-Earth L2 Lagrange point about a month later. The large sunshade will unfold to allow the telescope and instruments to cool to within about 40 degrees C of absolute zero. This will give JWST unprecedented sensitivity for making infrared observations of the early universe, the assembly of galaxies, the birth of stars and their protoplanetary systems, and will also probe the diversity of planets near and far, including looking for clues to the origins of life. In addition to these topics, scientists will use JWST to make discoveries that we have not yet imagined. JWST will be the premier astrophysics space observatory for NASA, the European Space Agency, and the Canadian Space Agency over its 5 to 10 or more year mission lifetime. It will augment the Hubble Space Telescope, which primarily works at visible and ultraviolet light wavelengths, in contrast to JWST in the infrared. JWST employs many unique technologies, and the mission has been in development for nearly 20 years. All major hardware components, including the telescope, spacecraft, and science instruments, have been completed. The integrated observatory is now being tested in California before it will be transported to its launch site in French Guiana next year. In this talk, I'll illustrate the mission's science potential and highlight the status of its development effort.